So I'm going to just go ahead and start doing some brief introductions before we start. We're 1 minute in already. So my name is Edwin Robledo. I'm part of the Fusion 360 family. I participate in a lot in creating content for our social media channels, as well as content for our help files, as well as content for our YouTube pages as well. And with me, we have Jorge Garcia. Jorge, could you tell us about your function over in community?
Yep, so my name is Jorge Garcia. I'm one of the community managers here with the Fusion 360 family. If you've posted anything on the forums, I've likely seen it and I've likely responded to you at some point. So it's nice to have you all join us here on the webinar.
Excellent. Hey, Benjamin, if you don't mind, could you give us a little bit about your background and let us know who you are?
Yeah, I'm a senior product manager for Fusion 360 Electronics. And so I've only been at Autodesk for 6 or 7 months. So I'm still learning the ropes, but it's a very exciting time. Background in electronics, I was at Altium for 16 years before coming to Autodesk. And just love electronics and design in general. So Fusion 360 is probably one of the most exciting things I've seen in recent times.
Excellent. Thank you, Ben. Appreciate it. And all those years that we met on different trade shows and now we're on the same fence, it's pretty cool. That's awesome.
Yeah.
The same side of things. And with us today, Matt Berggren, Director of Development of all electronics for Autodesk. Hey, Matt, could you tell us a little bit about you?
Yeah, so Matt Berggren, I run engineering for the electronics design software at Autodesk. Like Ben, long history in EDA, started at Excel EDA, which was a company that made a product called Pcb. Eventually went to then Protel, which became Altium. Left and eventually found my way to Autodesk, where I got really excited about the prospect of focusing on sort of the whole problem, design and manufacturing, end-to-end product development. So, but background in electronics, physics, semiconductors, quite enjoy the science side of things. Some of you may know me from Supply Frame, from Hackaday, from you name it. I kind of hang out in the same community as most of the old Eagle users. So yeah, been around the block a little bit.
So, Matt, I have to safely assume that, once you join Autodesk and Autodesk made the decision to go ahead and venture into the electronics, it was you that came up with the idea, says, you know what, let's go ahead and acquire Eagle.
Yeah, for better or for worse, it came through the wire that Autodesk was looking at getting into electronics design. And this is a pretty small community of people that have ever gone through the process of truly designing and managing and selling and operating, building an electronic design package. So I got tapped by some senior folks over at Autodesk to maybe consider coming on board. And initially, just to be sure, I wasn't very interested. I was outside of EDA. I was working at Supply Frame, which is vertical search, looking at search in the electronics domain. And as an engineer, that's a really fun problem. But decided after hearing the story at Autodesk, what was intended with Fusion, and that there would be this eventual convergence of electronics design and mechanical design into a single application that could do everything from design all the way through to manufacturing. That got a lot more intriguing. And I recall hanging out one weekend thinking over the prospect of it. And it's a big company. We could have conceivably acquired probably anything that was out there. And one of the things that was in play was Eagle. And I thought about it long and hard. And I thought, every other EDA package that's out there, and the packages that I worked on, were counting in the thousands of users. But Eagle had this enormous penetration, in large part because it was a free package. But there was this huge community of people. And if you ask an engineer, how do you build a product that has millions of users, we come up with nothing. But if you say, how do you build a tool that can do length to and differential pairs? Like, hey, geometry, I'm all for it. So the long and the short is we got to a place where I really wanted to see this convergence of design and manufacturing, and specifically smart products, intelligent things, consumer products, the sorts of things that the community of people that I was hanging out with on things like Hackaday.io or on Hackaday or on Hackster or on Tindy or any of those things, the things that people were trying to get off the ground. And sort of catalyzed by that, incentivized by that, that's what really set the stage for me joining the company. So sure enough, fast forward to the end, and we had acquired Eagle.
So now Eagle's been acquired. What's the plan? You know, at that point in time, 4 years ago, what were you thinking?
So, you know, interestingly enough, I'd been doing a bunch of workshops and teaching university kids how to design electronics, as well as people within the startup community in San Francisco. And the thing that really stood out to me was we were using Eagle in all of those classes. And I even made a quip at one point. I was teaching a class, I think down at University of Southern California. It might've been here in San Francisco, where I was saying, God, I wish somebody would just give me that code base for 6 months. I would rock that thing. Well, it turns out it took a lot longer than 6 months.
But you've rocked it, Matt. You've done it.
But we did, you know, I think we, I think
you rocked it.
Yeah, I think we did pretty well. We didn't.
Yeah, that version 7 was solid. That first one by Autodesk, that was a solid revision right there.
You know, it's come a long way, right? I knew what needed to happen. We needed obstacle avoidance in routing. We needed push and shove. We needed better tools for like semi-automated routing. You know, autocomplete on tracks, and you know, people tend to forget like all the stuff that we did with Eagle when we first acquired it. There was such a barrage of stuff that people should be forgiven for forgetting those things, because we were just firing stuff out there, and a lot of it was stuff that was coming directly out of teaching people how to build electronics or building them myself and using the product. There were just so many things that felt like we could modernize them pretty fast if we just had the right group of people. And so, you know, and that was a precondition for me coming to Autodesk, was I need to be able to bring my A team on board. I need these people from, you know, these various companies, because everybody that was sort of in my cohort had kind of disbanded and gone off and gotten other jobs in different places. But once we assembled that team, it was like the velocity was just there.
So the acquisition happens, and you're getting your A team to join the dream.
Yeah, and to really make good on some of the things that I had heard innumerable times, either teaching a class or just in the community of people that I hang out with. You know, geez, I don't know why Eagle does this. And then some of those things, interestingly enough, some of those things actually stood out to us as like, we didn't understand it, so we thought it was weird, and then we got into it, and then we understood that it made perfect sense. And there were a lot of moments like that. Like I had no idea why you would call something the cream layer. But I then realized that having enough experience on Unix, that two characters on Unix, super user, su, do, do, right, sudo, those two character expressions are like critical for the Unix user. TC for T-cream. Actually, if you look at the Eagle source code, the source code uses this starts with method that says, hey, does this string start with that? So you can shortcut the layer that you want to go to by just typing in the first two characters. And TC is differentiated from stop mask. So cream and stop would, if you called that solder paste, it would be TS and another TS, and those two things would collide. So, like,
That's what you were finding as
there
you
were
went
these
along.
hidden bits of genius that were not evident to me initially, and those things we've really. I've tried to be somewhat the keeper of keys and just really sort of carry the torch with some of those things, even though some of them are not intuitive to anybody. And I think, you know, it's incumbent on us to try to make those things more intuitive, but I don't want to throw those things away before we have a better solution for them.
So anybody that's joining us, you could go ahead and use the Q&A and direct it to Matt or to Ben, and we'll gladly take care of your questions. So,
Yeah.
so I'd like to direct our attention a little bit at Ben. Let's put Ben on the spot for a little bit there. So, you know, you've been a long time with Altium. I mean, 16 years. That's quite a ways. And then now you come over to Autodesk. Can you tell us a little bit about that?
Yeah, so, well, I would start by saying people don't know this about me because I was pretty well known in the Altium user base, being the guy that made all the videos that showed how to do stuff, right? But actually, before I joined Altium, I was an Eagle user. I was using Eagle up to about 4.05 or something like that. And then got my job at Altium and learned how to drive that and be an expert in that tool. So yeah, I always kind of had in the back of my mind that if I ever went to another ECAD vendor, it would probably be Eagle. It wouldn't be it wouldn't be one of the other sort of more expensive tools. But having said all that, the tool in 16 years, Eagle went so far, well, particularly in the last 4 since Autodesk acquired it. There were a lot of changes. So so that actually, I saw that. I was watching from afar, and you mentioned, Edwin, that we would see each other across the room at trade shows and things. And I just wanted to say a little side note about that. I do want to say you were the only competitor guy who was really super nice to me.
Thank you, Ben.
And so people pay attention. Like, being nice to people actually is really important. It's super important. You just don't know when you'll be working with them in the future, or when that kindness could actually open a door that would otherwise you wouldn't even go there. So I just want to put that out there. Edwin was always the competitor that would come to me and say hi and put his arm around my shoulder and say, "How you doing?" and thump me, and it was very nice.
So as project manager, Ben, could you give us some sense of direction? Are you trying to create another Altium? Could you tell us a little bit about that? What direction we're going in?
I think it would be a mistake to try to create another Altium. Altium, you know, I want to say it's a great tool, and a lot of people love it. Each ECAD tool out there has its strengths and weaknesses, but Altium, like many of the others, has been around a long time, and we don't want to just copy someone else because it's popular or because it's more expensive, or, you know, for whatever the perceptions are. One of the reasons I actually moved to Autodesk was I saw with Fusion 360 an opportunity to do things completely fresh and better than they've ever been done before, because there was a new team assembled. Eagle had the basics that make a great ECAD tool already. But the exciting thing was bringing that capability into a unified, the only really truly unified design environment. And something I realized as a designer myself, even when I was still employed by Altium, was I had my own licenses to other CAD software for modeling, because I need to make part models, I need to make enclosures. It's very common for electrical engineers to also do a bit of mechanical design here and there. It's not super common for mechanical engineers to do electrical design, but it's becoming more common. And even with, if you look at universities in the last 10 years, we've seen a surge of robotics and mechatronics disciplines growing, whereas traditional electrical engineering and mechanical engineering, they're still there, but the number of programs available that blend these disciplines with programming as well, to some extent, have exploded, and they continue to grow. So I just think that's the future is the future of design is smart products, and it's almost impossible to build something now. Even furniture, you're probably going to put something in it like a USB charger or some Bluetooth speaker, or I'm just throwing things out there, but I get ideas all the time, and every creative engineer out there gets great ideas all the time, and products are getting more and more integrated. So I think Autodesk was the only company that had that unique blend of easy to learn, easy to use, very accessible electronics and mechanical design and other technologies that gives us this clean slate to do things in a really different and exciting and far easier to learn and more productive way for the end user. So that's what sort of brought me over.
Excellent.
So guys, we have a few questions. Do you want to take a couple? People are actually being super nice and specifying who it's for, so it's pretty good.
Yeah, let's do it.
So Ben, here's one for you. Question from a Mr. Weber. How do you see the whole EDA circus now from your actual situation?
EDA, it is a circus, isn't it? I mean, there's a couple of things, and this also comes back to one of the reasons I was willing to even come to Autodesk. EDA traditionally required a massive investment, but the number of actual EDA users in the world is an order of magnitude, maybe 2 orders of magnitude less than software engineers and mechanical engineers. So just think about that. There in the world, there are not enough PCB designers. And so there's demand there there's good career opportunities, in my opinion, for PCB design. At the same time, there's very few. For every one PCB designer, there's probably 1,000 software developers in the world. So the investment required to make good ECAD is very high. It's just as high as any kind of other CAD, maybe even higher because there's esoteric natures to it. But the possible number of users is far smaller. So traditionally, EDA tools would have to lock in their users. They'd have to charge massively high licensing fees just to make that investment worthwhile. And that's why there's so few EDA companies and why they're so fiercely competitive. One of the things that CADsoft did, which really impressed me, was to open up their file format and make it XML based. And when they did that, that was what version was that, Edwin? That was probably version 6.
That was version 6. That's correct.
Version 6, right at the beginning of 6.
I saw that, and that was back when CADsoft Eagle was a Newark or Premier Farnell owned product.
Correct.
And I was really impressed. I thought these guys get it. This whole notion of the source of the user's design being locked in is stupid. And the CAD tools, because they're good, the users will love them. They'll stand on their own 2 feet. And it's a sensible, grown-up, mature thing to do, to say your data is truly yours. But our software, you will want to use our software because we make it better. And so we have to keep making it better so that you keep wanting to use it. It's gutsy, but it's the right thing to do.
Excellent.
And I think the whole industry's kind of at a turning point where we may be able to convince, but who knows?
Any other questions on the Q&A?
Yeah, for sure. This one's for Matt. So Matt, this is someone you know very well. If you look at the Q&A, you'll recognize the name. The last name starts with, the last name is Hughes, Mr. Hughes.
Mm-hmm.
Says, I used Eagle quite a bit around version 4. I really was tuned into using the command line and short versions of commands. To your point on commands accepting the first few unique characters, will this be carried forward into Fusion 360 Electronics? Once you get good at the command line, I remember Eagle being very quick.
Yeah. So, and Mr. Hughes, I hope you're staying warm out there. The command line is something that once you start to master it in Eagle, it becomes really hard to get away from. And I remember a point with AutoCAD in the history of AutoCAD where I think there was an intent to get rid of the AutoCAD command line, and the community pushed back pretty hard. Being on the outside of that, looking forward, or looking in, watching that happen, I realized pretty quickly what the value of that was. So I think the intent would be something of that direct kind of keyboard input. How that manifests, whether that's what AutoCAD does today. Like today in AutoCAD, you don't have to click in the command line. You can just start typing and the command line will pop up where you are. I think for what we want to do moving forward, it would be silly for us to get rid of some of that. But there's also some constructs in mechanical. If you've ever drawn something in a mechanical environment where you decide that you want to use some input, or you utilize some input on something, like if I create a mechanical sketch and just in drawing a box for a mechanical sketch, as you start to do it, you see the what we call the heads-up display, those input fields. So I can type 40, I can bounce over here and say 60. I also want to put heavy emphasis on those things because there are so many constructs like that in ECAD that you shouldn't have to go anywhere to do that. It should just be right at where you are. So think about naming a net, or think about defining a via size, all of those things where you end up like in Altium hitting tab and going into the properties panel, or in Eagle typing that into the command line. I think the mechanical tools have actually really gotten further ahead of most of the ECAD tools in terms of that kind of direct interaction and direct editing. Those are things that I think we want to balance against the need for a command line, so that we don't just race to do only a command line, but we think about that direct input as you're doing something. And then, further to that would be to constrain that, to say, I actually want to modify something and make it something else, so that there's this relationship between those two things, and a modification of one has the effect on something else. I think that's the kind of thing that also, just imagine that superimposed on top of PCB, which is probably a good point for me to bring up at least one slide in my presentation, Edwin. Not that we need to jump into the presentation just yet.
No,
but
I actually was going to tell you, maybe we should let's just show our guys what they're working on. I was going to actually just tell you right now, let's show what you're working on. Let's
Yeah. So let me.
If we can preface that. So for everybody who's asked, there was 4 years of release feature. Yeah. Why did it slop? Why did it slow down? Here's your answer.
I'll give you the long and the short. I can definitely give you an inside view, but the reason, so I was actually asking, Ben and I both asked the guys if we could participate in one of these webinars to really share the point of view and the perspective on what it is that we're doing, why we're doing the things that we are, why certain features have slowed down in different places, where we're focusing our energy right now, because you might not be seeing features coming out at the same rate into either Eagle or Fusion. And before we get into that, I just want to emphasize these are things that are in flight. Some of them will materialize, some of them won't, but your input will absolutely drive the direction. So what I don't want you to feel like is that you're outside of the walled garden as a community of users without influence over the product. So much of our time and energy has been spent trying to extract from the community what the biggest concerns were. And I think this is an important place to just pause for a second and say that when I joined Autodesk to take this on, I went to EEV blog and I went to Hackaday and I went to Hackster and I went to every forum that was out there, all about circuits. I love finding students putting my exam questions into all about circuits and then replying to them as though I don't know who they are. But
I have to ask you forgiveness, Matt, for heckling you when you went to EV.
That's all right. That's all right. There were plenty of people that that heckled me. Mr. Hughes, on the other hand, our community member who's in this discussion, he did not. He actually foretold the future.
Yes, he did.
But with just an incredible sense for the oracle of the upper Midwest, but I don't think that's really the Midwest anymore. But anyway, so I dug into all of those things and looked for the common threads, things like obstacle avoidance in routing, things like better polygon performance, polygon handling, SVG import. I know we're slow on that, but forgive me, we'll get there. Things like more flexibility in terms of just like board shape definition, interface to mechanical, better tools for semi-automated routing, autocomplete of things. Just there were so many things that were there. It was the target-rich environment. And so I actually went through and I created this giant spreadsheet, which was a list of everything that I found in all of those places. And I actually scored them all with a number next to them based on the incidence or the frequency in which those things occurred. Being the good engineer that I am, or maybe a modest engineer, but being the somebody who needs a structure to approach those things, we scored those things and gave them weight and said, okay, these are the things we have to do first. Hands down, this is what we need to do first. Then I took that and said, okay, and these are the people that I need to do it. And then I went out and recruited those people, brought them into Autodesk, got them introduced to the code base, and we moved forward with it. And all of this was happening as a background thread while we were going through the process of acquiring and then rolling out our first version. So that said, just everything that you see today, some of this is speculative. Comments like using the heads-up display and stuff like that, those are things that I really think we should do or will do. But I just don't want to try to imply that there's a specific timeline around anything that you're going to see today. Some things are fully formed ideas and they're already in development, but I'm not going to tip my hand on exactly when those things are going to come out. So that being said, let me kind of just give the whole community a high-level view, like an engineer's view of product design and specifically application development a little bit, because it'll help to sort of preface or help to contextualize some of the things that I'm going to show. Fundamentally, doesn't matter whether it's Fusion 360, it's Altium, it's Cadence, it's Mentor, it's Eagle, it's AutoCAD. All applications can kind of get summed to a few core components. You have something of a user interface or some system in which the user interacts with your application that when they click on something triggers an event. That event gets put onto a queue. That queue gets processed and that item gets put into a state machine. The state machine updates the data model, and with the change to the data model, we ultimately render that on the screen and return it to the view. Every application goes through this exact same pattern at some level. So when I got into Eagle's code base and we really started to understand it, all the fundamentals were there. All the right pieces, the core pieces were there. What we needed to do was figure out how do we extend that with the right technology so that the experience really on this half was absolutely bulletproof. And that we had enough in the way of an extensible data model that we could add new things. We could add a link to a 3D package. We could add a 3D package directly. We could add a spline to an XML file and make that sensible in an XML format. So that being said, I want to reflect for a second on what we started with. And it's by no means meant to as an indictment of classical Eagle, but what we started with felt like there was a lot of opportunity for us to improve workflow, for us to improve just basic graphics, for us to improve just the overall experience of the product. You know, we did a presentation actually at a Hackaday sponsored event here in San Francisco. One of my XD at the time, a woman named Tiffany Tsung, who absolutely brilliant XD, did a presentation about how when we introduced new icons to Eagle, everybody was like, why did you change the icons? And then she showed the old 16-bit icons from Eagle version 6 that people were complaining about. And the whole community laughed. But at the same time, there's something which is really important as a takeaway to that, which is an icon truly becomes iconic. If it's effective, people see it and they know what that command does. Their brain gets trained to go seeking that thing in the toolbar, in a menu, wherever it is. And making changes to those things, you've got to be really careful that you don't just throw out your best idea, but that you're actually sensitive to what the community will respond to as the natural progression of something over a period of time. So this is what we started with. And when we began the process of integrating Eagle into Fusion and really extracting that core of Eagle, which was the command processing or the command queue, some of the low-level code that was responsible for the state machine within Eagle, though we've certainly overhauled that significantly since we got it. And then the data model as well. When we sought to try to take that technology and move it into Fusion, this was also one of the prerequisites for us, for me coming on board at Autodesk and me really understanding whether Eagle was going to be the one, was we needed to know that we could separate the various layers of the application. You'll hear this oftentimes said by software engineers, sometimes correctly, sometimes misused, this idea of very tight coupling versus loosely coupled. And what we were really looking for was something in which there was the right level of separation of the various layers so that when we brought these things into something else, that we were going to be able to reuse a good deal of the code. It shouldn't matter what the context is. It could be in a web browser running on a server somewhere. It could be on the desktop. It could be on a mobile device. It shouldn't really matter. If the separation is right, we can deploy various things below various lines and build out an application around that with a different UI, a different command pipeline. So to the question about the CLI, there might be a version at some point in the far-flung future that has no CLI, because maybe that's not appropriate for some context, like on your phone. I'm not suggesting that ECAD needs to move to the phone. I'm not, I don't want to be a Kurzweil futurist, but the thing that I want to emphasize is that different contexts, there will be different input modalities, and we need to have the right separation at different layers to facilitate those different modalities. So I want to just introduce you guys to a concept, and this term has never been used outside of the company. It's a little bit probably controversial that I'm using it. So we got the core of the ECAD capability cleanly separated from its UI, from a lot of the command processing and command queuing and all of those various things. And there were some things that we realized very quickly. And it was actually the feedback from the community, but it was also the fact that, like, if you've opened up Eagle's splash page and you saw the tube amplifier that's on the splash page in Eagle, that was my tube amplifier. I designed it. And I designed it because I used the product. And this was always one of those things that I think makes Ben such a special person, George and Edwin such special people. We actually use the product and we build stuff. So I was working on this tube amplifier, and I decided that I was going to do it all in Fusion end to end. And I felt the performance challenges that the community was complaining about, switching between documents. There were just things like how long it took for me to place a part. It was great to go and get the library cache, but once the library was cached, everything was snappy. It was first that retrieval that was super slow. We looked at graphics performance, and coming from Altium, we were in somewhat a privileged position because Altium is very much driven around the GPU rendering with DirectX. And that was necessary for the 3D capabilities in Altium Designer. We knew that Eagle didn't have that graphics capability, and graphics performance is a big deal for PCB. So behold, Project Tokamak. I came up with the name just sort of tongue in cheek because we work on Fusion 360, and Tokamak reactor, if you don't know, is a nuclear reactor in which right now is kind of one of them that has the promise of a net energy output that's greater than the input. So it felt like an appropriate name for this project, that we would try to build the foundations right to catalyze an accelerated growth in the future. And this is actually where our head has been for the last probably 6 months, 8 months. So what you'll see on the right-hand side is actually what we're working on right now. That is a sketch-based PCB editor. And when I say sketch, I mean like the mechanical sketch environment. Now, we had to make some improvements to it because mechanical sketch is highly constrained, and the cost of those constraints computationally is actually very high. All the snapping and tangency and collinearity and orthogonality and all of those other constraints, all of that computation is happening at the CPU. Then you have the GPU side of that, which is rendering things. And it's really at the intersection of those two things that most sketch tools tend to bottleneck. And it sounds pretty benign, like, hey, you know, it's just a bunch of lines on the screen. How can that be harder than 3D? But AutoCAD contends with a similar problem, that just on the graphics front, imagine a hatched fill. Most people sort of forget these concepts, but let's take a sort of more extreme example. Imagine hatched text. When we say we could be drawing tens of millions of lines on the screen, the user tends to think tens of millions of routes. But hatching is something that predates textures and shaders and normals and, you know, all of these concepts that are advanced things in graphics these days. So hatching is one of those things that's actually really quite difficult to do. Not hatching your polygon, but hatching the lines that are in your polygon. Every one of those lines has to be rendered to the screen. So historically, Eagle rendered everything with a bitmap. That's what we got when we acquired Eagle. And we knew that. And we knew that it was a problem that the people that I was going to bring on board were capable of solving. So we brought the people on board that know how to solve these things. And hey, it's Autodesk, right? If we don't know geometry and rendering, I mean, there's virtually no Academy Award-winning film for visual effects that isn't using a piece of Autodesk software. We kind of know that stuff. So I was banking on the fact that Autodesk had all the right core technology to really accelerate some of these things. I guess no pun intended, but to really accelerate not just graphics and rendering, but also just performance in general. So what we've been working on is Sketch, but taking the classical Eagle or ECAD approach and saying, let's superimpose that instead on that front end, which is a Sketch environment. And then let's optimize Sketch graphics and Sketch constraints so that we don't constrain everything like the mechanical world does, but we have the right level of constraints to look for collinearity and orthogonality and tangency and all those things. So what you see on the right-hand side is real. Got it on my computer. You might even see a little bit of it. And we did all the right sort of separation. We've also done the GPU optimization, and we've moved all of the rendering to use the GPU. This is what we've been working on. And I wanted to be transparent with the community that from where we started to where we were going, there was one thing that we were ignoring, and that was the long lead time problem, which was how do we get the core disciplined to be able to deliver the functionality that you want in the future? And how do we then consume or make available to us all of the technology that the mechanical engineers have been the beneficiaries of for a really long time, like constraints, like a heads-up display. So that's been a huge driving force in what triggered us to finally bite the bullet and say, step one, give the Eagle community as much of the functionality that Matt was able to extrapolate from every forum post, from every forum that I could find, from every piece of feedback that I would get from a friend or a frustrated student. Let's deliver against that so people know that we're not here to kill it. In fact, we're not focused on anything other than accelerating the future of whole product design and manufacturing. But to do that, we have to do some hard work. So our team has looked at using Sketch, going native with Sketch, and that's an intended future. I think we can probably confidently say, without any promise of any timeline on that, that's what we're working on. As far as the other stuff that we had to do structurally, good API isolation, building out our test suite to be able to test every layer of the application. So if something is broken, we can catch it with automations, following something which is much more consistent with how the web is tested, and applications being built on the web. Moving the graphics system to using GPUs, to using shaders. That one was just obvious. We had to do that to get the performance that we wanted. And then developing a level of consistency with UI and with the UX of the application to give you one UI toolkit that presented everything in a pretty consistent, pretty uniform way, but didn't take anything away from the electronics user. And then I think the last thing which underpins everything that we're doing is we needed to hit the performance envelope that we felt confident with. When you switch between documents, it should be instantaneous. When you drag off a tab and you open up multi-monitor, it should be fast. All of those concepts need to be things that we dedicate ourselves to focusing on, because the community has spoken, but also the crotchety old guy who's running the show from an engineering standpoint gets just as frustrated as everybody else. Ben and I have done both collectively enough FPGA boards in our lifetimes to know what it takes to do fairly significant, fairly substantive boards. And so with his help and with a team of people, many of whom are both software engineers and have an electronics background, I'm pretty confident we can move it forward. So here's kind of the punchline. We got to a place and I said, well, will it work, right? So in this video, you'll see Eagle's zoom performance, and I apologize to people in Ireland and Munich and things like that. If you see excessive frame drop, just assume that Eagle is slower. But this is zoom performance on 4-up BeagleBone. And like, this is not that sophisticated. I mean, it's a fairly sophisticated board by classical Eagle standards, but it's not that sophisticated. And this is the same zoom behavior in the sketch environment that we've built out now in Fusion. And what we found is we could hit very easily 30 frames a second, 40 frames a second, which is kind of a simplified shorthand way to describe performance. It's not always going to be that way. But we could hit 30 frames, 40 frames per second, no problem, with 4-up BeagleBone in a design, zooming and panning and other things. Eagle was drawing a bitmap. Every frame was updating a bitmap. And you don't do selective pixel editing on a bitmap. So in this case, we can draw the things that are on the screen and ignore the things that aren't. Because we can do a lot of this optimization on the GPU side. We can also use shaders to draw all of these things and have better transparency and better highlighting and all this other stuff. So, this was actually one of the tests of, is it going to be fast enough if you consider hatching and other things in that? So I decided, and my first test was with long strings of opening scroll text from Star Wars, but I decided that I was just going to load this thing up with text and see, how's text going to render? How fast is it going to be? Can I still zoom? Can I still pan? Can I still highlight? This has a lot of stuff in it. And still, by sort of every conventional measure, it's what you should expect an ECAD tool to be able to do. And coming from Autodesk, I just did a bit of a thought experiment, took as much text as I could find in one blob, pasted it into AutoCAD and said, can AutoCAD do this? Sure enough, AutoCAD can do it. AutoCAD can hang on to the blueprint for a 100-story building. So, what are they doing for 2D that the rest of the world hasn't caught on to? And so as we started to explore that, got to know the AutoCAD team pretty well. And it was really this type of thing that we were looking for. That sort of, how do we hit test something so that just dragging your mouse over it, it's highlighted? Those sorts of concepts might seem like, well, yeah, every tool should be able to do that. But when you talk about the numbers of objects and the fact that not every pixel is actually being drawn on the screen, so you may not have something visual to hit test against on the GPU, the optimization of that is non-trivial. So we really wanted to push the envelope. I don't want to have to answer the performance question 5 years from now. I want to answer the 5-year from now question today. So this is, part and parcel of what we had looked at. It's only one example. I don't want to say that this is the only example. We did everything else. We looked at the UI and we said, okay, how do we improve the overall experience? How do we build out an experience which doesn't just feel like every other CAD tool that's out there? Because I think Fusion is pretty unique in that it really tried to kind of scope down much of the interface so that you don't feel like you're surrounded by millions of buttons and menus and things where you've got 3 layers of menu. So on the left-hand side, interestingly enough, in this picture, on the left-hand side, that's a mock-up by me, which is a testament to the fact that you should never ask Matt to do a mock-up. And it was, my first swing at just trying to get my thoughts down. If layers and colors, for example, were a panel, what would it look like? And could I move between them? Could I enable them? Could I lock them? Could I delete them? Could I add them? Could I build layer sets from it? If that was just a docked thing, but it could be dragged off and floating in space, maybe even on a second monitor, I could still interact with it and still have full access to the canvas on the primary screen. Those sorts of concepts were things that, you know, when I looked at it, anybody who's used Eagle before has dealt with that. And this will probably be the only disparaging thing that I say, that wonky 64 box grid where the first row of colors is the color and the row below that is its highlight color, but there's nothing telling you that except in the Eagle help file. I wanted to move away from that. The software needs to be intuitive. So when you open it up, you look at it and you can just use it. So left-hand side was my otherwise pretty daggy mock-up. And you can see where having a good XD person has helped to improve a bunch of the experiences. On the right-hand side, you can see how you might expand this out to enable selective layers for things, but then collapse it. You might choose, you know, specific layers that you want, or you might want, you know, to route this on any layer. You know, this is actually the quick route airwire command, and you want to be able to control the via and the via shape and all of those things in the midst of the routing, but you want it to be right there. Now, combine that with something like the heads-up display, and you start to get this view of where the experience is going. We don't want it to be flowery. We want it to be functional. I don't just want pretty pictures. I want something that's functional. Things like the ability to change what material definition I have and decide whether or not something is going to be included in 3D. Some of those things persisted and kind of made their way all the way through. But from the ideation phase to the use of that in the midst of a command, we've evolved a lot of these capabilities. Something that we're paying particular attention to, because I think there's a lot of frustration around this, is libraries. There is an enormous effort underway right now to really hone in and improve the library experience. My feeling after talking to some of the more notable community members, Cameron, big shout out to you. It wasn't until talking to Cameron that I found out that Cameron always placed parts from the control panel in Eagle. And I thought, wait, really? He never went into the add dialog. He used a control panel, and it stuck with me. Other tools have a list of parts there all the time. Doesn't go away. It felt to me like continuing with the add dialog, the way that the add dialog was, that's not something that I want to continue to persist. Unless there's strong resistance to it. I think if you think about the tool in terms of what you do, place parts, wire them together, label the signals, push that over to PCB, place those parts, adjust the board outline, route things. You sort of want all the primary information to be available to you. But then you also want those things to be in a format where if you want the entirety of your screen real estate for a board, that you can drag something off like a docked panel to another interface or another monitor or something and reserve some room so you can have the entire workspace available to you. So those are things that we are pushing really hard on. And I understand, you know, there was a lot of confusion with Library IO and why Library IO, and I just made a comment about this on the forums.
I don't want to be rude, Matt, but we're at the 5-minute marker and we have a lot of Q&A. So
okay, no sweat.
Well, actually, that's a good point too, because Matt, you were just getting onto libraries, and a few of the questions, for example, from Mr. Henson and some of the others are about libraries.
Yeah, well, fire away. Let's talk about them before we move on to kind of the last big thing.
So the first one, Mr. Henson, is Managed libraries step in the right direction, but lots of steps are still manual. Library sharing is still a bit clunky between distributed teams. How will Fusion 360 Electronics handle libraries? And more specifically, will it support more automated data entry and better workflows between distributed teams?
The short answer is yes, all of that. And actually, there's some quite big projects underway right now to move largely in that direction. That will help all of those different areas.
Yeah,
it'll take us some time.
Definitely.
It's one of the priorities for right now, actually.
Yeah, Ben's prioritized libraries above everything else.
Yeah, the other question is, and it's related to libraries kind of tangentially, when will the team turn its development focus to improving BOM-related activities, such as the ability to edit attributes of multiple components at once? Currently, adding and editing manufacturer and part number information in order to generate a BOM is a painfully manual process.
Yeah. So
can I link that question to the one by Mr. Wilson about intelligent outputs? Because to me, I kind of let's just talk about the overall output generation.
Yeah. So let me not in the interest of anchoring us around slides, but in the interest that it's relevant. So, I build a bunch of stuff, Ben builds stuff, George builds stuff, Edwin builds stuff. And, the workflow kind of looks like this, right? I go to DigiKey looking for a part, or I go to Mauser or Arrow or Avnet or whomever. I plug in some information. I use their search to find a part because it's really second to none. If I want to understand the dynamics of a part, where I can buy it from, who has it, how much it is, I use FineChips. It came from SupplyFrame, so FineChips is owned by SupplyFrame. I'm quite comfortable with what it does, but it's also got some really whiz-bang stuff. So then I go to FineChips and I try to figure out, like, hey, where can I buy this in the quantity that I want? One of the things that we want to focus in on is bill of materials and attribute handling. So one thing I'm working on scoping right now is a parts list. The idea being that someplace you want to record what part you want to use. And at some level, you actually want then to link that part as a virtual thing, a thing that you found on the web, to an actual part in the library. And you should be able to have all of your actions hanging off of that. Whether that's, hey, I want to use a 555 timer, or I want to use an STM32 or a NRF chip or whatever it is, right? I want to add it to a parts list because I know I'm going to use that part. I want to link it to the source. And then subsequently, I want to be able to, over time, depending on the number of those that I add to a design, I want that same part list to increment the quantity of those because I am steadily approaching a bill of materials. And that is one of the things that we're also looking at right now. So it goes everywhere. It sort of covers the whole range of attribute handling to bill of materials to output generation. And I just want to be sure that folks get a feel for the fact that, this is one of those things that we're very actively working on. So we are going to address it.
I was gonna ask Jorge, maybe we could just go through the Q&A questions.
Yeah,
I know Matt had a lot more to cover, but we're like down to the minute, and I was hoping that we could get as many answers as possible.
Well, no, he finished the presentation, so that's good. So Matt just basically answered Mr. Brenneman's question, but Ben wanted to dovetail that with Mr. Wilson. So Ben, if you want to answer Mr. Wilson, go for it.
Yeah, the question was that basically are there other plans to support going to PCB assemblies with more intelligent formats?
ODB++, IPC 2581, things like that is his question.
I would say we're not in development on anything like that now, but it's certainly within the scope of future considerations. So we spent a lot of time talking about this performance issue. Once we've gotten the lion's share of that done, we'll be filling our development pipeline with some of these other things. One of the things that's exciting about Fusion in general is that it's not just a modeling tool, it is a manufacturing tool. So in the mechanical side, you have CAM, you have drawing, like a really powerful set of drawing tools. And this is the other reason we wanted to combine that with electronics, because we can use some of those powerful technologies to get things like nesting for panelization, just as an example to throw it out there. So part of that will be down the road reviewing all the different areas of CAM and seeing where for electronics CAM we can make those improvements. And I think it goes beyond just sending data out. It's also about getting good data in as well.
Excellent.
Yeah.
We have like 4 questions asking about the future of Linux support. So I guess, I'm going to ask it because we can kill like 5 questions that way. What's the plan, or is there a plan for Fusion 360 to support Linux, and any variation of that question you can think of?
So I'll just, I'll tackle that one head on, because I, for the longest time now, ran a build and release team that looks at platforms that we build on. There's some investigation that we started into that. I don't want to set false expectations, but there is an appetite to explore it. So if you think about the nature of engineering process in an organization, the exploratory is a really important phase of that, and it's got to be a funded exercise. I can say that the exploration of that is something that we're looking at. It really just depends in large part on third parties, because we use third-party libraries for some things. And if those third-party libraries will build in a favorable way on Linux with minimum amount of diverging from the primary branch of that code, meaning that we're not trying to patch somebody else's giant library, then it makes it possible. Nothing that I've seen thus far would prevent us from doing that. But the devil's in the details. And so I think it's something that I am actively promoting internally in the company to say, let's chase this.
Excellent. Here's an easy one. What is the plan for scripting tools going forward? UOP is powerful but has limitations. Can you explain how the Python scripting engine will integrate with Fusion 360 Electronics?
So my intent is to, so right now we're actively trying to make Python scripting work correctly. I would prefer that the electronic stuff, in keeping with the separation of concerns, that the electronics capability maintain a Python library that is accessible through Fusion, so that interacting with ECAD, you would interact with the core ECAD engine, and then you could create scripts in Fusion that would be all based around Python. But if that's done as a library, you could also build anything else you wanted around it with Python.
Excellent. Looking forward, is there any interest in implementing any support of electromagnetic field simulation in Fusion 360?
Short answer is yes, but how and when that appears is yet to be determined. There's a lot I could say on that, but can't, because it's kind of under wraps right now. But we're certainly aware of the need. There's not one consumer product on the planet now that probably doesn't have at least some kind of high edge rate device inside it that could cause EMI problems, and the regulations for products to meet certain standards are only getting more strict. So we do consider it a necessity to help people meet those requirements, and if that means investing in simulation technology in some way or something, that certainly is on the radar. So I'd say watch this space.
Yeah, yeah, and it's it's a broad space, right? It
Yep.
really depends on if you're trying to solve a signal path problem or if you're trying to solve a genuine product EMI problem. And those are sort of both two different sides of the same coin. Because some simplified 2.5D field solving can address the signal path problem, but then the S parameter sort of other side of that is oftentimes actually out of reach of most people, and I think we've got to make a pretty significant investment in finding ways to make that accessible above all else, because if it's not accessible, it still remains the domain of wizards and witches. It doesn't become practical for the current user to be able to apply it to something. So it's got to be straightforward to use.
Okay,
Absolutely.
we're 5 minutes in, guys.
If they still can, and I don't think we've lost anybody, I say we finish.
I was gonna ask maybe Ben and Matt to give us maybe some final thoughts, and those of you that if we have not addressed your question, we will be on the forums, so we could address those as well. I will be posting this recording, this live stream, on our Fusion YouTube channel as well. So I was hoping to give some final thoughts to Ben on the direction that we're going, as well as to Matt as a final word.
Yeah, well, the underpinning theme really to Fusion is making the design and production of consumer products really easy. And so that's kind of our North Star for what we want to do. So there's a lot going in right now besides performance onto general usability. We're doing a lot with, and I recognize some of the names on the webinar today as people we've even interviewed to get a lot of customer feedback. And I really just want to reiterate that all your feedback is very, very valuable and helps us. There's two sides of it. One is we could make a faster horse, or we could make a motor vehicle. But I think pretty much everyone's in the motor vehicle market nowadays. So there's a lot going into libraries. There's a lot going into general usability and workflow optimization. He's not on the call with us today, but we actually have a dedicated XD guy who's really, really good and helping us to sort of clarify our thinking around the look and feel of the product and some of the workflow steps where there's just too many clicks, or we find things can get bogged down. So we're streamlining as much as we can as well. So there's a lot coming. It takes a while to get there, but that's why we're doing this webinar today, to make sure people understand we're really investing in this.
Yeah, and I'm hoping to put together some other ones as we go along later on. So
Yep.
I would like to end with Matt and his final thoughts on in our direction, the development, and what do you have to say, Matt?
Well, I'll just sum it up in saying, I'm super interested in feedback from the community. Don't think that we are ignoring the feedback. We're pretty actively trying to be as responsive as we can. Some problems are just long lead time problems. Improving libraries was one that we had to do for a long time, and it's something that we're working on. I really hope that I managed to give you guys confidence, the fact that we're thinking about many of the same things that you're thinking about. You guys probably, if the savvy ones picked up that I just synchronized a schematic and a PCB that were out of sync with each other because I added some components to schematic, but you guys can watch the video later for those that didn't catch it. All of those sorts of problems we are actively looking at and trying to maintain a sane, sensible approach to tackling them one after another in a very deliberate way. we're going to continue to work hard. We are not going to cease to invest in what we acquired or this community. I want to make sure that that you guys hopefully walk away with a sense of confidence that that's a priority for us.
Thank you, Matt, so much. Ben, thank you very much. Jorge, as always, splendid work. And I would like to, and Matt used this expression the other day. We just had to slow down a little bit. That way we could move forward a lot faster in the near future.
Yeah, slow down, speed up.
That way we could. So if you haven't seen a lot of things going on, it's because there's something big coming really soon. So Thank you so much for everybody joining us. Appreciate it. Those that were able to attend, thank you so much. I know we went over a little bit, but the recording will be available. That way you can see the rest of it. Have a great day and stay safe. It's been a pleasure.
Thanks, guys.
Thanks.
Bye, everyone.
Good to see you.